Okay, we have looked at the history of information systems and where we've been. Let's take a quick look at where we are today. In a modern information system, all data is stored and manipulated digitally. We no longer use analog technologies in any meaningful way. We still get analog data that goes into the system. If you record something on your computer, take a video, etc., you're recording analog information, the sound of your voice, the visual field that you see on your screen. However, that data is immediately converted into digital data. So when you speak into a microphone in your information system, that microphone leads to a piece of software that converts the sound waves of your voice into ones and zeros. It does the same thing with all information. So everything today is digital. We have a law, what's called a law in computer technologies in general, called Moore's Law. And Andrew Moore, who was one of the founders of the Intel Corporation, quoted this law that says that computer processing speeds double at an exponential rate. And his general estimation was about every 2 years they double. And that was because at the time we were getting better and better at packing smaller and smaller transistors onto microchips. Microchips were getting denser and more powerful all the time. Now, Moore, since then, has said that his law no longer applies, that we've reached the physical limitations of how dense we can make a microchip. However, we get this rising exponential curve still because other things besides the computer microchips continue to develop at an exponential rate. So information systems are still growing very rapidly in speed and capability. The system that you install today is likely to be obsolete in just a few years. Now, modern computers, fast, interconnected, and they use a lot of standard software. At one time, when computers first became available, if you wanted them to do something, you had to write the software yourself. Today, you can buy most of the software that you need, both the operating systems and the applications that your computer uses. And because we're all now using very standardized sets of software, we can communicate and share data and other functions much more easily. Everything you see around you today is a computer. Not just the things we call computers. Those smartphones that you might have in your pocket, it's just a computer. It has a microphone and a speaker that convert sound information back and forth from digital to analog because your ears hear analog, but your smartphone generates data, stores it, and forwards it in digital form. It has some software that allows it to communicate to cell towers and to use the wireless systems and other wireless connections to share information with other telephones and other computers. So it's not just a phone, it's a computer. If you have a reader, a Kindle or a Nook, it's a computer. So many things today are computers, we just don't call them computers, but they have the ability to receive, to send, and to process digital information. Data storage, our ability to capture data and to store it in one place, has also been described by Moore's Law. We're now at a point on the planet Earth where most of our data, the majority of human data, is stored in information systems. It's stored electronically in digital formats. That's pretty impressive when you think we've now got more digital bits than we have information stored on paper in books and in paper files. We have been storing information on paper and carved into stone and other physical formats since we invented written language. We've only had digital data for less than half a century, and we have already significantly exceeded the amount of data being stored by digital information. That's impressive. It looks like it's only going to continue as we get better and better at storing data. Right now, most of that data is resident on something called server farms, on row after row of computers, each one of which has a very large hard drive. If you look at Google or you look at Facebook, one of the very large online operating businesses, they have gigantic server farms. They have the ability to store truly breathtaking amounts of information and to find exactly what you are looking for within microseconds when you ask for it. Telecommunications today. I think I've already mentioned that most young people today have probably never dialed a rotary dial phone, and it's just something you see on old movies on television. And you may have never or very seldom spoken to a telephone operator to ask for human assistance in making the connections. Modern telecommunications are largely transparent to us. People make cell phone calls all the time without another human being involved, with no real idea of how that information actually gets to where they're sending it. So what this allows is something we call networking, connecting computers to make larger and larger and more complex information systems. We have a lot of different choices today about how we would network. We have information networking systems that are completely wireless, where the computers have no physical connection to each other. We can use a satellite to talk to somebody on the other side of the planet. Broadband is an increasing area of technology. We have more and more ability to do that. And then ultimately the internet, which is the network of networks. It is the single largest communication system on the planet today. And this allows the production of extremely complex, diversified networks. This is pretty typical of today. Lots and lots of computers, some of which we call computers, some of which we call something else, talking to lots of different storage places, lots of telecommunications mechanisms, and interfacing with lots of users in lots of different ways. So remember, what looks amazing to us, if you're just fascinated with modern technology, it's going to look very primitive to your grandchildren. Your children will think it's sort of complex. I know this because I have children of my own, and they laugh at my understanding of technology. So if you think you already understand a lot about technology and you're wondering why you need to go through this course at all to pass that CLEP test, no matter what you understand about technology, it's going to change and change soon, so don't get cocky. If you have any questions at all, I'd encourage you to watch this video as often as you need to. Also, go to the website, review the reading materials that are recommended for additional information, and take a shot at answering the questions for this block. Thank you.